Hello everyone. I hope you guys are doing well. Last week I was quite busy, and I couldn't get a time to solve the lead code questions. Actually, in my organization, we are working on a new project, and that is from the scratch, and I am part of that design. So I am currently working on that architecture part. And when you work on any new project from the scratch, you need to do a lot of things, like you need to see the security stuff, how your security will look like, and also you need to identify what sort of infra you need. Also, you do the cost analysis. Let's say if you deploy something on the container, Kubernetes, or something on the Lambda functions, or something on like ECS or EKS. So you do a lot of comparison there. You do see the cost analysis also, and finally you come up with the design, right? So that's the reason I was quite busy. Still, that work is in progress right now, and but today I got some time, so I thought let's continue this series. So far we have solved 9 questions. Today we are going to see this 10th problem, jump game part 2. In the previous video we were solving jump game part 1, and today we are going to see this 10th problem. If you want to see those previous 9 videos, I'll do one thing. I'll add this link into under description sections so that you can find this series. You can go through those 9 problems, and today we will try to solve this 10th problem. Okay, let's start with this jump game part 2. This is going to be similar like part 1, but here let's see what they are asking. So if you have not seen the previous video, I would recommend go and watch first that part 1, and then this one you will easily able to understand. So let's try to understand what they are asking in this question. So in this question they have given us one array as an input, and here in this array each element represent the maximum length of forward jump from index I. So we saw in the previous question also, they gave one array to us, and they said for on each like this value is nothing but a maximum jump you can do from this index. In the previous question they were asking us to return true or false whether we can reach to this last index or not, but here they are not asking that one. They are asking we have to return minimum number of jumps to reach to this position. So let's try to understand this problem with example, and then we will try to write a code. So the example is 23114. So 23114. Okay, so the example is 23114, and what they are asking, to reach to this index, to reach to this position, we have to count minimum number of jumps required. That's count we have to return, right? What we have to return? Count, and the end we have to return. So let's say if you start from this, if you can go to this position, right? You can make a 2 jumps, and then from here you can go to this, and then from here you can go to this. So how many jumps you did? One, two, three, right? And what else you can do? You can jump, take a 1 jump from here. You can to reach to this, and from here you can again take a 1 jump. From here you can take a jump, and from here you can take a jump, right? This is another possibility. So how many? One, two, three, four. Here you're taking a count as 4. Another thing what you can do, you can go from here, you can directly jump here, right? So how many? 2. And another possibility, like you can go to this, and from here you can take a 2 jumps, and from there you can take a 1 jump. Here total count is 3, right? One, two, three. And then you can at the end you can take a minimum of this, and output would be your 2, and that's your answer, right? If I see the answer of this is 2, the minimum number of jumps to reach the last index is 2. Jump one step from index 0 to 1, and then 3 steps, right? That is what they are saying. But if we go with this approach, it will take a lot of time. Like we need to write a recursion logic. We need to find all the combinations, and then we need to return minimum, right? So we are not going to write, that's not going to be efficient solution. So we'll try to solve this in a efficient way. Let's try to understand that how we can going to write a efficient solution. Okay, so let's try to solve this with this example. 3, 0, and then say we have given 1, then 2, then 1 and 1. So what we have to return? We have to return a minimum number of jumps required to reach to this last index, right? So we need a count, right? Definitely we need a count variable, and we also need maximum reach variable. If you've seen previous video, what we are calculating maximum reach, how far we can go in this array, right? And also one we are going to apply a greedy algorithm here. Like we at a very first place we assume that we can reach to this last position. So we will say we don't know what is the value here, right? So far, so here initially and will be 0. Okay, now these three things I'll initialize, and then I'll start a loop from index 0 to n minus 1. Okay, and in the loop first I'll calculate max reach. Okay, what would be my max reach? If you see in the previous video how we are calculating max reach, like current this reach 0 max function comma how we calculate how far we can go from this index value I plus what is the value it's given. So 0 comma I is 0th index, what is the value given? 3. So max of this is 3, so maximum reach would be 3. From here we can go till this index, right? We can go to this index, right? We can go to this index. This is maximum reach, and my count will increase because I am going to take a jump here, right? I'm going to here take a jump, right? And also, what is the how far I can go from this index? What is the boundary or what is the end? My end would be the maximum reach. What is the maximum reach? So right now 3, right? Till 3 I can go, right? And I'll apply one last condition here. If this max reach, same condition we applied in the last program as well. This also we did in the last program. This also we did in the last program. If max reach is greater than equal to last index, then it means we have reached to the last index. Then here we will break the loop because we know we have reached, and at the end we will return our count, whatever the count value is. Okay, but okay, so let's see when I is equal to 1, when I equal to 1 here, what is my maximum reach value? This 3 comma index 1 plus this value 0 means 1. So my maximum reach is still 3, right? I can go till this place only. That's the maximum reach I'm saying for this array, right? But I don't want to do anything here because I'm thinking applying greedy approach. I'm saying from directly I'll go here, right? So I'll not do anything at I equal to 1. So this I don't want to execute. This I don't want to execute. And your maximum reach 3 is still 3. 3 is greater than last index. No, I don't know. I'll not break the loop. So I don't want to execute. You remember, I don't want to execute this condition. I want to execute this conditionally. We will see. Then now I is equal to 2. When I equal to 2, I'm here. My maximum reach is still going to be 3. And I don't want to do anything here. I don't want to do anything. So this will not, I don't want to execute. So when I want to execute this condition when I'll reach to the end of this value, right? When I is equal to end, then I just want to execute this. Now we'll see. Now my index value is now I equal to 3, right? I equal to 3, 3. And what is the value max end contains? It's 3. It's 3, right? So this will go inside this loop. It will increase the count value again. It will increase the count value. Now count will become 2. Now count will become 2, right? Now count will become 2, and from this position, what is my maximum reach now? See, if you calculate maximum reach at I equal to 3, what would be the maximum reach? Max function. Your previous reach was 3. Now current index is 3 plus what is the value given there? The value is 2. So max 3 comma 5. Your maximum reach would be 5, right? From this index, third index, I can. So I don't want to do anything here, right? So it will not go anywhere in this loop, and I got it like my maximum reach is 5 now, and 5 is greater than equal to last index. Yes, I'll break the loop. My count is 2. I'll return that count. So let me write that logic, then definitely you will be able to understand. So what we are going to do, we will initialize these values, we'll run a loop, and then we will calculate max reach. We did same thing in the last program also, and then we will put one condition when we reach to that end of that particular index, and if I equal to that end, then we will just increase the count, and if max reach is greater than last index, then we'll break. Okay, let me write that logic here, and then we'll see. So int count equal to 0 we need it, and then we need int max reach equal to 0, and then we are saying that and 0, then we are applying logic and nums dot length -1, and then we are saying I plus plus. So what we are doing, first we are calculating max reach. What is the max reach here? Max reach is how we are going to calculate. We will use a math function. Math, what is the current max reach? This is, and then to calculate how far we can go is, this is the formula, right? And then we are saying that, let me first write this logic. If max reach becomes greater than equal to at any point last index, right? What is the last index? Nums dot length -1. I'll I'll return. I'll break the loop, right? And but I have to calculate count also, right? So I said I'll increase the count always. So here I said I'll increase the count, and also I said like if I equal to when my current index will reach to the is matching with that end position, when I have reached to that end of that value, then I'll increase my count that time only, and my next end would be new max reach. Whatever max reach I've got it, that my new end will be this max reach, right? This is what I had to do. I think this is what we did, and then here we will simply return count. Okay. Okay, this is what we discussed. Let me try to run this. Hopefully this will work. Let's see. Okay, something is wrong. I've done it. This is something. This is okay. This is looks okay. Max reach we have calculated correctly, I believe. Then we are saying and okay, and this falls into this. Yeah. Let me try to submit this again. One more thing. I think this is not going to end it here. One second. This come here. Yeah. Accept it. Submit. Okay, 99.46% beats, and all test cases passed, and logic is this one only. It's a similar logic we have written, just one extra condition we have added this one, and this is a greedy algorithm where we can think that okay, from this position I can reach to the last, and then when I reach to this end, then again I'll update my end value, and again I'll jump from there. So that's how we solve this one. Thank you, thanks for watching this one.